Hi guys, today we'll be factoring using different methods, the greatest common factor, difference of two squares, and perfect square trinomials. Ready? Let's go. First, let's start with the greatest common factor. So first, we have a problem, a squared times b minus a times b squared. Let's throw a number in there. We want to factor this. So we take out what these two terms have in common. They both have a. You take out the lowest power, so a. And we also take out b. They both have b in common. And what do we have left? I call this like the distributive property backwards. So a times how many a's will give me a squared? One more a. Then b times what will give me b? It'll be 1, so we leave it there. Then we have ab here times what will give me this up here. So we need the number 3. And then we already have a. We took a out, so what do we have left? We need another b. So let's do distributive property and make sure we did it right. This is our answer, our factored answer. But just to check it, I do ab times a will give me a squared times b minus 3b times ab, which will be 3a times b, which makes b squared. When I multiply those two, that's what I get, and that's my original. So let's make that 2 a little better. That's my original, so I did it correctly. And that's how you factor using the greatest common factor. All right, we can do another one like that. Let's call this a, and let's call this b. Let's say we have 3x squared minus 4x to the third y squared. All right? So what do they have in common? Well, they both have x's, and you take out the lowest power. So we want to factor this. So we get x squared. And then we take x squared out. So what do we have left? We have 3 minus 4. We took x squared out. So how many x's do we have left? If we take away 2, we have 1 left, x, and we also have y squared. This is our factored answer. So what do we do to check it? We do distributive property. All right, so x squared times 3 gives us 3x squared. X squared times this gives us our original, because x times x squared will give us x to the third, and then we have the 4 and the y squared already there, so that's how we check it. All right, and that's how we do the greatest common factor. Now, we will use the difference of two squares. Some students call this dots. Difference of two squares. We will factor by using the difference of two squares. So if we factor x squared minus 144, well, we have two perfect squares here. X to the second power minus 12 squared. There you go. These are our perfect squares. So when we factor it, our factored answer will be x minus 12 times x plus 12. All right, the difference of two squares, our formula is if you have x squared minus y squared, then it'll be, the factor form is x minus y times x plus y. Doesn't matter which one you put first. X minus y times x plus y will be our answer. So that's why this is our answer. This is our factored answer. If we want to check it, we will do FOIL. If we do FOIL, we get x times x is x squared. And x times this is 12x. Negative 12 times x is negative 12x. And negative 12 times 12 is negative 144. What happens to the middle two terms? They cancel each other out because they're opposites. X squared minus 144 is our original. That means we did it correctly. Let's factor 2x squared minus 8. What's going on with this problem? That's not a perfect square, and 8 is not a perfect square. So we have to do what? The first thing you learned. Take out the greatest common factor. What do these two terms have in common? They both have 2. When we take out 2, we're left with x squared minus 2 times what gives you 8? 2 times 4. Good job. All right, now you have to factor again. So we took out 2. Now, what What does this remind you of? The difference of two squares. This is x squared minus 2 squares. Dots. Difference of two squares. That's where it comes from. Alright, so we got x minus 2 times the quantity of x plus 2. And that is our factored answer. If you want to check it, you would do FOIL, and then you will multiply by 2, or you could do 2 times each one here. 2 times x times 2. Let's just do it, because I don't want you to be confused. Alright, so we're going to do 2 times x times each one. We get x squared minus plus 2x. Then negative 2 times each one is negative 2x minus 4. And what does that give us? These cancel out. They're like terms. So we get x squared minus 4. And that equals 2 times each one, distributive property. It's 2x squared minus 8, which was our original, so we did it correctly. Alright, and that is how we use the difference of two squares. Now we're going to use perfect square trinomials. Perfect square trinomials. We're going to factor perfect square trinomials. Alright, now our formula is if we have a plus b, quantity squared, that's the same as a plus b times the quantity of a plus b. And what does that equal? That equals, if we do a times a, we get a squared. A times b, we can do FOIL. And then b times a and b times b. So that's plus a times b again, plus b squared. So our actual formula equals a plus b, quantity squared, equals a squared plus 2ab's, that's the like terms, plus b squared. This is the perfect square trinomial. Alright, you will use this a lot in calculus, and algebra 2, and maybe trigonometry. Alright, you are going to see that if you have a square here, a perfect square here, the first term, a perfect square at the end, in the middle, if you have 2 times a and b, then that means you have a perfect square trinomial. Okay, you don't have to do the long methods to factor. Alright, what if we have a minus b squared? Then that's going to look like this formula, but it's going to be a squared minus 2ab plus b squared. Alright, these are the perfect square trinomials. We're going to factor these now. So, let us do an example. X squared, we're going to factor x squared minus 26x plus 169. Now, you can try this at home. So, we're going to factor x squared minus 26x plus 169. So, what do we want to do first? We want to see if we have perfect squares. In the front, of course, we have x squared. We have the number in front, which is 1. That's a perfect square. And then at the end, we have 13 squared. Alright? So, in the middle, we want to check to see if we have 2 times a times b. Since there's a minus sign here, we're going to look at this formula here. So, we have 2 times 1x, which is our a, and then our b will represent 13. 2ab. Alright? Is that true? Yes. 2 times 13 times 1x is 26x. That means I can just go straight to my factoring form, which is, what's my a? My a represents 1x, minus sign because of this, and my b represents 13, and I square it, and that is my answer. That's the factor form. If I want to check the answer, I could actually multiply it out and do FOIL. Alright? But we're going to keep going. We are going to factor again. 36 x squared minus 84x plus 49. Wow, these are some big numbers. Now, if you tried to do those methods, slide, divide, you would probably be like, whoa, your brain is going to explode. So this is now, what's the square root of 36? It's 6x squared. And what's the square root of 49? It's 7. So this is a perfect square. Damn, they're both perfect squares. So what do we notice? In the middle, if it's a perfect square trinomial, the middle term has to be, let's make this a plus sign, everybody, okay? Let's change this to a plus sign. The middle term has to be 2 times a times b. So, do we have that? we have 2 times, let's see, 6x is a, and this will be b, which is 7. So if this is my a squared, this I want to be 2 times a times b, and this is my b squared, and I have a plus sign here. That would mean if this is equal to 84x, that's a perfect square trinomial. What is 2 times 6, everybody? 12. 12 times 7 is 84x. Yes, it's a perfect square trinomial. I don't have to do the long method. So when I factor, my answer is the factored form over here, which is my a plus b squared. What's my a? Sorry, my a got a little messed up there. A is 6x plus, because it's the plus sign here, b, which is 7 squared. That is my factored form. Thank you for joining us. Perfect square trinomials, you can factor using dots, difference of 2 squares, and don't forget the greatest common factor. Always check that one first, just in case you got to take something out first before you go doing all these methods, okay? See you soon. Hi guys. Today we'll be factoring. No.